Okay, today's lesson, lesson number 3, is all about normal distribution. So we're going to talk about the normal curve and different percentiles. So I don't know if you want to read through the do now. You guys can pause me and look through it and answer those couple of questions. But it's kind of nice because it's about SATs and how they show your score and stuff. So, talking about percentile ranks, a percentile rank is a number between 1 and 99 that shows how you scored compared to other students. It represents the percentage of students who score whose score falls at or below your score. So in other words, if somebody is in the 57th percentile, they scored higher or equal to 57% of the test takers. So you're going to see 2 percentiles. In this, you're going to see the nationally representative sample, and that percentile compares your score to the scores of typical 11th and 12th graders, and the user percentile, which compares your score to the actual scores of recent graduates who took the SAT. Okay, so now analyze the data report of this SAT score from the student shown. So they got a 1350, looks like 94th nationally representative percentile, and then 91st in the user percentile. And they break it down into your math and reading and writing. So the first question is asking what percent, I should say, of students who score above this individual according to the SAT user percentile. So here, your user percentile is right here. They're in the 91st percentile. But it says what percent of students would score above? So the people that scored at or below is 91. The people that scored above would be 9% of that 91st percentile. Okay, does that make sense? The percent of students, okay, what percent of students scored at or below? Okay, totally different question. So now it's pretty much going to be the percentage that you're seeing of the reading and writing scores of this individual for the SAT user percentile. So here's your reading and writing, and the SAT user percentile, if it says at or below, here, at or below, it's that number, which is the 86th percentile. Okay. So right now you are looking at the normal distribution. This is all normal curves have that same overall bell-shaped looking symmetrical curve. Any normal distribution is completely described by 2 numbers. The mean, mu, and the standard deviation, which you see there, which is the population. Okay, it's your full population. So we talk all about different important reasons for your normal distribution. Okay, your normal distribution, they model standardized test scores like the SATs, ACTs. They model real measurements in nature and in the real world. And for the most part, they are the foundation of statistical inference. Okay, while many sets of data are normally distributed, there are a lot that aren't. You're going to keep in mind that the sets of data so important are always going to talk about the mean and the standard deviation. You need those pieces of information to set up your bell curve and your normal distribution. Just because you know a mean and a standard deviation doesn't always mean that your set is normal. We usually need to be told that it is a normal distribution, or the data is normally distributed, something like that. So there is this empirical rule that you're going to see, this 68, 95, 99.7. So in a normal distribution, if you look, okay, from your center, which is going to be your mean, 68% of your observations are going to fall within 1 standard deviation of the mean. Okay, this means 1 standard deviation of the mean. So just take note, mean, standard deviation, and those are your symbols. So within 1 standard deviation, it's 68%. Within 2 standard deviation, it's 95% of your data. Within 3 standard deviations, it's 99.7% of your data. So normal probabilities are represented like that. Now, if you look underneath this, they used to give this to you on the regions. They do not anymore because they kind of have like summarized it with these 68, 95, 99.7 rules. But if you look, you see the actual numbers, okay? So if you see within 1 standard deviation, okay, well, you could see that here. Within 1 standard deviation, you have the 15, the two 19.1s, and the other 15. And if you added those up, you would get 68.2%. Okay, so within that 1 standard deviation is 68.2%. Okay, and then if you add it up within 2 standard deviations, so I'm just going to go a different color, I think, like literally from here all the way to here, it's like 95.4%. Okay, and then if you go out to 3 standard deviations, it's 99.8% because you just have that 0.1% on either side. Okay, so you kind of see where those numbers are coming from. If I did from here 3 all the way to here 3, it's like 99.8%. All the way to that 3. Okay, just so you can kind of see that. So it's funny, sometimes you're going to see more of just that roundabout numbers, 68, 90, 95, and 99.7. And sometimes you'll see they're actually adding up the exact numbers that are in within 1, 2, and 3 standard deviations. Okay, so let's look at Tiger Woods. Okay, so this says, on the driving range, Tiger Woods practices his swing with his driver by hitting many, many balls. Suppose that when Tiger hits his driver, the distance the ball travels follows a normal distribution. Okay, so they're immediately telling us it's a normal distribution, so we could set up the curve. And we have a mean of 304 yards, and the standard deviation is 8 yards. Okay, so I want you to understand immediately, if you're drawing this, the first thing you know is that the mean, right in the middle, this is the mean, is 304 yards, okay? And every time you go above or below a standard deviation, you either add your 8 yards or subtract your 8 yards. So if I want to go above my standard deviation, 1 standard deviation above would be 312 yards. 1 standard deviation above that, which would be 2 standard deviations from the mean, I would just add another 8, would be 320 yards. And another standard deviation above that, which is 3 standard deviations from the mean, would be 328 yards. Now, if I want to work backwards and go a standard deviation below the mean, I'm going to subtract that 8 and get 296 yards. And if I keep going down, 288. 1 below that, 280. So that is showing my normal curve above and below the mean, 3 standard deviations above, 3 standard deviations below. Okay, so now I'm just going to show you a couple of ways to do this. They're now saying what percent of Tiger's drives travel between 296 and 312 yards. So you could see that right from here. 296 to 312. Does everybody see that? That is literally above and below 1 standard deviation from the mean. Okay, so one way you could do that is to add up all of those decimals. So you would literally say 68.2. It would be your 15, your 15, your 19.1, your 19.1, and you could say 68.2%. Now, the other way technically you could show that is by saying okay, it's just everything in between. So like the other way I would say, if you're going within one standard deviation, if I want to like literally sketch that little curve, and within one standard deviation below and one standard deviation above, that's everything above and below one. You could also say 68%. So either one of them I would accept as the answer, 68.2 or 68%. Okay. In the second part, they say to you, what percent of Tiger's drives travel more than 312 yards? So if you look at that, more than 312 yards are the two standard deviations above 312, which would be everything from here out, right? Does everybody see that? So when you think about above that first standard deviation, it's going to be your 13.6, right? You're going to add 13.6. So where am I getting 13.6? Come back here. It's your everything above 1 to 2 is 9.2 and 4.4, which gives you your 13.6. And then if you add above your second standard deviation, which would be 1.7 and 0.5, which would be 2.2%, plus your extra little 0.1%, would give you 15.9%. So one definite way to do it, everything above that first standard deviation. Now, what's your other way to explain that or show that? If you think about your curve, okay, and it's everything above your first standard deviation. So think about it. That would be 1 minus your 68% divided by 2. Because if I wanted, think about what I know that whole middle section. So this is really what you're looking for, everything above 1. And if you know the whole middle is 68, take away 1, the whole thing is 100%, 1 minus 68%, and divide it by 2, you're going to get 0.16 or 16%. So 15.9, 16%, you'll know approximately where you're looking at, right around there, 15.9 or 16%. Okay? Okay, let's look at the next one. What percent of Tiger's drives travel less than 288 yards? Okay, so less than 288 yards is here. So here's your less than 288 yards. That's under 2 standard deviations. Under 2 standard deviations is your 1.7, your 0.5, and your 0.1, which is your 2.2% plus your 0.1%, which gives you your 2.3%. Now, if I want to think about my curve, okay, and think about, this is what we're talking about. This is underneath the 2 standard deviations. That's where 288 was, right? Everybody sees that. So think about within 2 standard deviations. Within 2 standard deviations is 95%. So take 1 minus 0.95. That's going to give you the 2 outer sections. But we don't want the 2 outer sections. We only want one of the outer sections. That's why we divide by 2. And if you do that, you get 0.025. And if you approximate that, well, if you show it as a percent, it's 2.5%, which is approximately 2.3%. Again, those 0.2%, that 0.2% is just going to be rounding, because in your normal curve, when we're doing the empirical study, which is just the 68, 95, 99.7, it's not calculating those tenths, that 0.2, that 0.4, that 0.8. Okay? Okay, the last one says provide an interval that contains the middle 95% of Tiger's drives. Okay, well, your 95% is obviously, and you should write this down, 95% is within 2 standard deviations. So I'm going to make this a new color. I'm going to say here, okay? So 95% is within this. Okay, this is your 95%. So I would say 95% is within 2 standard deviations. So technically you see it here. Within 2 standard deviations is above and below 2 standard deviations, which was from 288 yards to 320 yards. Technically, how can I show that? I could show that I would take the mean minus 2 times 8, which would be 304 minus 16, which would give you your 288. And you would take the mean and add 2 times the standard deviation, which is 304 plus 16, which would give you your 320. Okay, so that's your interval. Okay, all right, so that's kind of by hand. So now let's look at another way we could do this. So the empirical rule is great for any observations that is exactly 1, 2, or 3 standard deviations from the mean. So if you notice, all the questions had to do with exact numbers above and below 1, 2, or 3 standard deviations. But what happens in real world when it's not exactly 1, 2, or 3 standard deviations above and below the mean? Okay, so to find normal probability on GeoGebra, you're going to be using this. Normal, okay? And this is what you're going to type in. It's called the normal CDF. You're going to see it down here. Normal CDF. And just know that CDF stands for cumulative distribution function. So I am just going to write cumulative distribution function. Okay, and we'll get to that in a second. But when you are typing this in on GeoGebra, I'm going to show you how to do it. It's gonna say normal CDF. I think actually it just says normal. You're gonna see this normal, and then you're gonna input after the parenthesis the mean, the standard deviation, and then the value that you're looking for. So now just understand this. This is going to compute the probability, okay? It's going to be given as a decimal. That probability is going to be, I'm just going to write that as a decimal. Okay, so if you want to convert it to a percent, you could move it as an x-coordinate value to the left. So here's what you have to understand. If you want the probability below a value, its distance from 0 to the value, 0% to the value, it's going to be the value that it's given. Think about the do now. When they said, oh, it was the 86th percentile, that means that score you scored at or below 86% of the people. So when you're just looking for this, okay, below a given value, at or below that value, it's what it's going to be given. If you are looking for everything above that value, so very different, above the value, you have to subtract that value from 1 or 100%. And if you're being asked, oh, the probability between 2 values, when you're computing 2, you're going to have to find both and then find the difference between them. Okay, so that's really important. Okay, so it says, now we're going to try the whole Tiger questions using the calculators. So watch this. Are these the same numbers? Are we giving 296? Yeah. Okay. So it said, what percent of Tiger's drives travel between 296 and 312? Okay, so this is like choice 3, when it's between 2 values, okay? So when it's between 2 values, we have to go into the calculator. So I think that I'm going to go straight into here, okay, and I'm going to click on my three dots, and you are going to search NOR, normal. You're going to see normal. When you open up that parenthesis, remember, you're going to put in first the mean. Here the mean was 304, comma. Then you're going to put in the standard deviation. Here his standard deviation was 8. And now in this question they want between two different numbers, between 296 and 312. So first I'm going to do 296, and I'm going to get that number. 0.1586, blah, 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 blah. Then I'm going to do it again, okay? I have to calculate both. So I'm going to do my normal again, my mean 304, my standard deviation 8, and now I'm going to use my other number, because it had to be between 296 now and 312. And there's that number. Now, when I subtract them, I want obviously a positive probability and percentage. So I'm going to take B, which was a bigger percentage, bigger probability, and I'm going to subtract my A. Okay, and look at that number. So if I had to write that number down, 0.682689, 0.682689. This says, does it say what to round to? The nearest 10,000th. Okay, so 10,000th, I'm going tenths, hundredths, thousandths. This is the 10,000ths place. So that 8 tells me to make it 0.6827. And this would be my answer. So if you see, that's about what? 68.3%, which is pretty close, 68.2%, which is what we said before, or about 68%. Okay, so that's using your calculator versus if it's, not exactly one standard deviation above or below. Okay, so let's try that again. Look at the next one. In the next one, they say, what percent of Tiger scores are more than 312 yards? So more than 312, I'm going to erase these two. Okay, and I'm going to show you 2. 2 says above a value, subtract from 1 or 100%. Okay, so if I go into my calculator, I don't know if is it easier for me to just bring it up next to it? It might be. Okay, so I am going to clear out that first one. And let's talk about above 312 yards, more than 312. If I go into my normal, and I'm going to go back to my 1, 2, 3, and I want always the mean first, then your standard deviation, and then the number they're talking about. Here, 312, right? So look at that number. Well, I don't want that. I want anything above that number, I have to subtract from 1. So I'm going to make my life easy and do 1 minus and use the letter A, because that's the letter they assign to that. So there's my answer. So again, here's what I'm going to write for you. I did normal. I did the mean, comma, the standard deviation, comma, that 312. That gave me this number of 0.8413, 44, and so forth. But then don't forget, because it's the one that's above, I have to do 1 minus that number. Okay, and when I do that, I get 0.1586, 0.158655. Okay, so what they want us to round to, I think, again, the nearest 10,000ths. So 0.10ths, hundredths, thousandths. Here's your 10,000ths. That's going to be 0.1587. Okay, and that would be your answer. And what is that approximately? Approximately 16%, which is what we said before in choice C, or 15.9, which is exactly what that would be rounded to the nearest tenth. Okay? Okay, I'm going to do that next one. I did it in purple. Okay, so what percent of Tiger's drives are less than 288 yards? Okay, so look here. This is if you are finding below a value. So it's just going to be the number that they give you. So here you're going to go in and do normal. Your mean, your standard deviation don't change. But now I want everything below 288. So here, when I bring this next to me, I'm going to do normal. I'm going to do my 304, comma 8, comma 288. And that's my number. 0.0227. Okay, so 0.0227. Yeah, 50. Okay, so tenths, hundredths, thousandths, 10,000ths. I'm going to make that number become 0.0228. And that should be my number rounded to the nearest 10,000th. So what is that as a percentage? Oh, I don't know, about, we said 2.3 or 2.5%. Technically rounded to the nearest tenth, 2.3%. Okay, so good for you guys to know these numbers and how to put it in the calculator. Okay, so let's try some more. In 2013, approximately 1.6 million students took the critical reading portion of the SAT exam. The mean score and the standard deviation were calculated to be 496 and 115 respectively. Okay, so your mean is 496 and your standard deviation is 115. So if the critical reading scores are normally distributed, that's really important. They have to tell you that. They're normally distributed. Which interval reflects 95% of the scores? Okay, so here's what you need to know. 95% is within plus and minus 2 standard deviations. Okay, so a couple of ways you could do this. You could literally just take your 496, which is your mean, and you could add 2 times 115. Why 2? Because you got to go 2 standard deviations above, 2 standard deviations below. So 496 plus and minus your 230 has to be your answer. This is within 2 standard deviations. If I wanted within 1 standard deviation, then I would pick choice 1. That's only within plus and minus 1 standard deviation. Okay? Okay. How about number 3? In number 3, it says the distribution of the diameters of ball bearings made under a given manufacturing process is normally distributed. Okay, mean of 4, standard deviation of 0.2. What portion of the ball bearings will have a diameter less than 3.7? Okay, so I am going straight to the calculator. Okay, here's what I know. I know here, God, my thing is terrible. All right, let's make that a nice straight mean, right? So right here is my mean, and that's 4. And I know that my standard deviation is 0.2. So I could keep going up by 0.2 or down by 0.2, right? So here's what I do know. I need to know, I'm going to use my calculator. I'm going to say, well, to get my percentage or portion of everything less than 3.7, I'm going to take my mean, comma, my standard deviation, and use my 3.7, right? So that 3.7 is not exactly, because one standard deviation below 4, do you agree, would be 3.8. So the next one here would be 3.6. That 3.7 is somewhere in the middle, go blue, of the two standard deviations. Okay? So let's use the calculator and make our lives easier. So I'm going to say, I'm going to go to my normal. I'm going to put in my mean, comma, my standard deviation of 0.2, comma, my 3.7. Now, because this is everything at or below, that should be your answer. Your answer should say 0.066807, right? Something like that. So when I look for that number, it's choice 1. Okay, about 6.7%. Okay. All right, let's try for the light bulb question. Number 4, it says the lifespan of a 60-watt light bulb is produced by a company is normally distributed with a mean of 1450, standard deviation of 8.5. Okay, so they want to know what is the probability of its lifespan between 1440 and 1465. So here's where you kind of have to calculate both and then subtract your numbers. So literally, here's what I'm going to show you. You're literally going to do normal. Okay, your mean is 1450. Your standard deviation is 8.5. I'm going to show the bigger one first, 1465. And whatever that number is, you're going to subtract it from, once again, your normal, your mean, your standard deviation, and then your smaller number. Okay, so I am going to go straight into the calculator. I'm going to clear all this out, and I'm going to do my normal, my 1450, my 8.5, and then my bigger 1465. Okay, and then I'm going to once again calculate the other one, my normal, my mean, 8.5, I think I did 85, 8.5 was my standard deviation, and my other number was 1440 for the number of hours. Okay, so I have to subtract those. So I'm going to show A minus B. And that should be what I'm looking for. 0.8414, blah, blah, blah. Okay, so it was something like 0.96119 minus 0.11970 gave me 0.84148, which had to be choice 3. Okay, so again, there's 3 different ways to do it. In other words, if it's everything below that percentage or below that number, you just have to put it in, and that's the answer you're looking for. If it's everything above that number, you got to take that answer and take it and subtract it from 1 or 100%. And if it's like this one, between 2 numbers, you have to calculate both and subtract to get a positive answer. So the bigger minus the smaller. Okay, so let's try these 5 and 6. In number 5, the weight of a bag of pears at a local market averages about 8 pounds. So there's your mean. Okay, I'm going to just mark that as your mean. And they tell you the standard deviation is 0.5 pound. The weights of all the bags of pears at the market closely follows a normal distribution. Super important, they're telling you that. Determine what percentage of bags to the nearest integer. So now we're talking a whole number. So let me just write that. We're talking whole number, weighed less than 8.25. Okay, so this is the easiest to me. When it's less, all I have to do then is do normal. Okay, your mean is 8. Your standard deviation is a half. And you want everything less than 8.25. So when I go into my calculator, I am going to clear this out and do normal. I'm going to do my 8, my 0.5, and my 8.25. 0.25. Okay, and there's my number I get. About, okay, what do they say to the nearest integer? So it's 0.691, I'm going to write first. 0.691, which is about 69.1, so I would say 69%. What percentage? Whole number, 69%. Okay, so literally if I wanted to show my curve, not the greatest, but good enough, right? And I know my mean is 8, and like one standard deviation is obviously 8.5. So this that they were talking about kind of line right here, right in the middle, 8.25. Okay, it was everything below that 8.25%. Okay. Okay, let's try one more and see how this goes. The ACT is a standardized test. We know about that. The ACT has a mean of 21, standard deviation of 5. Explain why it would be appropriate to use the normal distribution to model the ACTs. Okay, so you don't even have to calculate anything. Okay, so your mean is 21 and your standard deviation is 5. Explain why it would be appropriate. Well, the ACT is taken by many students, and a standardized test is a good model for a normal distribution, right? Standard exams are given to a very large number of people, are usually modeled by a normal distribution. So I would just say the ACT is taken by many students and standardized tests model a normal distribution. I think that's good. Standardized exams given to a very large number of people are usually modeled by a normal distribution. That should be perfect. Okay, so that's going to stop the lesson, which is good news. And now you could just try some example problems. You have 7 questions. Let me know if you have any trouble, and I will try to help you through this. Okay, talk to you.